Okay, this is the second part of example 1. They also want us to find the length and compare the length of ms to the length of a to e. And to do that, we're going to use the distance formula. And just as a reminder what the distance formula was, the distance formula is subtract the x's, that's the distance in the horizontal direction. Then you square them because we're going to have them under the square root. But before we take the square root, we're going to find the vertical distance between the points. Okay, and from there we're going to use the coordinates there. Now we got to remember what the coordinates were. We found that this was 1, 2, and we found that this was 5, 0 using the midpoint formula, and they gave us this one as -1, 1, and this one as 7, -5. So if I list them here, use a different color. For ms, I'm going to call this x1, y1, x2, y2, and then well, let's go and find that distance from m to s. So the distance from m to s is going to be, and I recommended that you just write it with the minus signs, the double negatives don't trap you, and then we can put the numbers in. And so I've got my x's 5 minus 1 and my y's 0 minus 2. So ms equals square root of 4 squared plus -2 squared, and you get 16 plus 4, and ms is the square root of 20, which reduces to the square root of 4 times the square root of 5, which is 2 root 5. Remember, square root of 20 is the square root of 4 times the square root of 5, and the square root of 4 is 2. So I need to remember that number there. So I'm going to put a box around it in red. So I'm going to have to do the same work, but this time I'm going to have to do it for A to E. I'm going to have to use it for A to E right here. So I'm going to change the number. So I'm going to erase some of the stuff. Just erase all that. Erase this. Erase that. And then we can just change the letters there, and we'll just reuse that stuff. It might save us some time, I don't know. So this will be AE is going to be, well, I'm going to write it in. And then I'm going to write AE here. And I've got the same number of steps here. So let's write those stuff numbers in black. This is x1, y1, x2, y2. And so we get the 7 is the x2 minus -1. And then we've got -5 for y2 and -1. Okay, and so we get this becomes plotting, so we get 8 squared plus, we've got -5 plus 1 is -4 all squared. So that's 64 plus 16. So if I skip this step here, you're going to get AE equals, well, 64 plus 16 is the square root of 80. And if you just stopped there and compared these two, you would think it's 4 times bigger as the normal is what you would think. But it's not really 4 times bigger because it's the square root of 4 times bigger. What is the square root of 4? Square root of 4 is actually 2. It should be 2 times bigger. And I'll show you, this is where simplifying the radicals is important, because you can see that multiplication factor much easier. So let me break down the square root of 80. 80 is the square root of 16 times the square root of 5. And the square root of 16 is 4. And the square root of 5 is just the square root of 5. So we actually have solved this thing. Right here. And it's much easier to see that you multiplied by 2. The number that you multiplied by to go from 2 is times 2. So what did I notice here? This is what I noticed, is that the mid segment is half the side the third side that it's not intersecting. Okay, that's what I saw there.